Welcome to this session of Finite Element method. In this session, I will going to discuss about methods to solve any engineering problems, my dear students. So, here is for solving any engineering problem, there are three methods are available, my dear students. The first one is experimental method, second one is analytical method, third one is numerical methods, my dear students. So, there are three methods are available. To solve any engineering problem. So, under this, first one is experimental methods, second one is analytical method, third one is numerical methods, my dear students. Numerical methods, my dear students. So, first of all, we will discuss about experimental methods. So, here is a experimental methods, my dear students. So, in this experimental method, what is the parameter we have to find by conducting experiments only? For example, tension test. To find change in length of the mildest specimen by conducting tension test on that specimen. Okay. So, in that experiment, a mildest specimen is present. That is, a physical prototype is available to find the change in length. Okay. A physical prototype is available to find the change in length for that specimen. That is a physical prototype. Okay. All of it clear, my dear students. For conducting that test, it takes a time, and also expensive setup is also required. Universal testing machine is required. That is expensive setup, and also time. It takes a time to find the change in length of the MS specimen, mild specimen. Okay. Next one, for getting good results for change in length, minimum 3 to 5 prototypes must be tested. Otherwise, we are not able to get good results, my dear students. So that in experimental method, whatever the parameters are measured, that are actual values, that are actual measurements. Okay, that is the first point, my dear students. Actual measurement. Whatever the parameters are measured, that parameters are actual measurements. Actual measurements, my dear students. Next one, time consuming and expensive setup is required. Now, this method is applicable only if the physical prototype is available. Otherwise, it is not applicable, my dear students. So, applicable only if physical prototype is available. Okay. Next point, my dear students. The results cannot be believed blindly by taking or by testing one specimen. It doesn't give good results. For getting good results, minimum 3 to 5 prototypes must be tested. I will write that one also. So, results cannot be believed blindly. And the minimum 3 to 5 prototypes must be tested. Must be tested, my dear students. What are the examples for this? Just now we are already discussed here. That is the tension test. To find the change in length of the mild stress specimen, by using the change in length, we are able to estimate stress and strain. Fatigue test. Fatigue test, my dear students. Strain gauge. Sensors for pressure and temperatures. Etc. my dear students. All of it clear? So, it is about experimental method. The next method is analytical methods, my dear students. Analytical methods. All of you see, my dear students. In this method, these methods are based upon some assumptions. For example, for deriving bending moment equation and twisting moment equation based upon some assumptions, my dear students. Okay. Next one. Now, this method is applicable only for simple problems, that is cantilever beam, UDL, point load, UVL, simply supported beam, point load, UVL, UDL. For these beams, we are able to derive the equation for bending moment and slope and deflections. So, for any type of beam, we are able to find the slope and deflection by using the formulas. But this analytical method, these formulas are available only for simple problems, not a complicated problems, my dear students. It is applicable only simple problems like cantilever beam and simply supported beams. But here, although the results getting from analytical method is a approximate results. If the solution is not a closed form, that is, suppose for example, slope at a particular, for a beam at a particular point is 1.0025 like this. It is not a closed form. At that time, it also gives approximate results, my dear students. But in general and broad sense, this approximate results considered as a closed form of solutions, that is 100% accurate, my dear students. All of it clear? So, I will write each and everything. So, analytical methods are based on some assumptions. Based on some assumptions. Next point is here. Okay. Applicable only for simple problems like cantilever beam and simply supported beams. Yes, my dear students. Though analytical method gives approximate results, if the solution is not a closed form. If the solution is not a closed form, my dear students, but in general and the broad sense, analytical method considered as a one minute, my dear students. Considered as a closed form of solution. That is 100% accurate. That is 100% accurate, my dear students. All of you clear? See a small mistake here. 100% accurate, my dear students. 100% accurate. It is about the analytical method, my dear students. Next one, numerical methods. For any analytical description of a physical process or physical phenomena, we are developing a mathematical model. That is, first of all, it is a mathematical representation, my dear students. For any physical phenomena, we are developing mathematical model. That is nothing but mathematical representation. So, the numerical method is nothing but, first of all, it is a mathematical representation. Next one, here also, this numerical method is also based upon some assumptions. It also gives an approximate results, my dear students. Okay. So, it is approximate assumptions made here. Next one. So, these numerical methods are applicable even if a physical prototype is not available. But in case of experimental method, physical prototype is must and should. But here, if the physical prototype is not available, at that situation, we are applying these numerical methods, my dear students. So, applicable even if the physical prototype is not available. Now this method is applicable for a real life complicated problems. For that there is no physical prototype, my dear students. So real life complicated problems. The real life complicated problems are solved by using numerical methods. Real life complicated problems. By using this method, we are able to solve a real life complicated problems, my dear students. Next one. Whatever the results are obtained from the numerical methods, that cannot be believed blindly, but it must be verified with experimental results. Or hand calculations for knowing the range of results. We have to know the range of results by using hand calculations. We are comparing these results with experimental method and hand calculations. That is very important here. Next here one is results cannot be believed blindly. Results cannot be believed blindly and it must be verified with. It must be verified with experimental methods. And hand calculations for knowing the range of results. For knowing the range of results, my dear students. All of it clear, my dear students? It is about methods to solve any engineering problem, my dear students.